National Electrical Code Article 680.23 IFR addresses the requirements for electrical wiring and equipment near swimming pools. Specifically, it states that all electrical wiring and equipment within 5 feet of the inside wall of a swimming pool must be buried at least 18 inches below ground level. Alternatively, it needs to be otherwise protected. This requirement is in place to ensure electrical safety and prevent potential hazards associated with water and electricity. Considering the context of a light niche conduit running within 5 feet of a pool's inside wall and being installed in a concrete deck form, the NEC 18-inch burial depth requirement likely applies. The purpose of burying the conduit at least 18 inches deep is to provide a physical barrier and protection against accidental damage, such as digging or other construction activities. It also helps to minimize the risk of electrical shock in the event of a fault or insulation failure. The concrete deck form itself may offer some degree of protection, but it may not be sufficient to meet the NEC requirements. The 18-inch depth requirement is intended to provide a standardized and reliable level of safety, regardless of the specific construction methods used. It's crucial to understand that the NEC sets minimum standards, and local codes and regulations may have additional or more stringent requirements. This means that the local authority having jurisdiction, or OJ, may have specific rules regarding conduit burial depth near swimming pools. These local codes may be based on factors such as soil conditions, climate, and specific hazards present in the area. Always consult with the local HA to confirm the specific requirements in your area before starting any electrical work. To ensure compliance and safety, firstly, identify the location of the conduit in relation to the pool's inside wall. If it's within 5 feet, the 18-inch burial depth requirement typically applies. Secondly, review the applicable NEC article, specifically 680.23 IFR, to understand the general requirements. Thirdly, contact the local HA to confirm any additional or more stringent requirements in your area. They can provide clarification on local codes and regulations that may impact the installation. Fourthly, when installing the conduit, ensure that it's buried at least 18 inches below ground level, or provide an equivalent level of protection if allowed by the HA. Use appropriate conduit materials and fittings that are approved for underground use and designed to withstand the environmental conditions. Fifthly, properly seal and protect all conduit connections to prevent moisture from entering the system. Moisture can lead to corrosion and electrical faults, compromising the safety of the installation. Sixthly, ensure that all electrical work is performed by a qualified and licensed electrician who is familiar with the NEC and local codes. They have the expertise to ensure that the installation meets all applicable requirements and is safe for use. Remember that electrical safety is paramount, especially in areas where water is present. Failure to comply with the NEC and local codes can result in serious injury or even death. Always prioritize safety and consult with qualified professionals to ensure that all electrical work is performed correctly and safely. The NEC provides a comprehensive set of guidelines for electrical installations, but it's essential to understand that it's not a substitute for professional judgment and expertise. Experienced electricians can assess the specific conditions of the site and make informed decisions about the best way to ensure electrical safety. Here are some additional points to consider when installing electrical conduit near swimming pools. Firstly, use only listed and labeled electrical equipment. This ensures that the equipment has been tested and certified to meet safety standards. Secondly, install ground fault circuit interrupter, or GFCI, protection for all electrical circuits serving the pool area. GFCIs are designed to detect ground faults and quickly interrupt the circuit, preventing electrical shock. Thirdly, bond all metal parts of the pool structure together. This includes the pool shell, metal ladders, and any other metal components that could become energized. Bonding helps to create an equipotential plane, reducing the risk of electrical shock. Fourthly, maintain a safe distance between electrical equipment and the pool water. The NEC specifies minimum distances for outlets, switches, and other electrical devices. Fifthly, regularly inspect the electrical system for any signs of damage or deterioration. Look for cracked or frayed wires, loose connections, and other potential hazards. Sixthly, if you have any concerns about the safety of the electrical system, contact a qualified electrician immediately. Don't attempt to repair electrical problems yourself unless you are properly trained and equipped. Proper grounding and bonding are critical for electrical safety around swimming pools. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse into energizing the circuit. Bonding connects all metal parts of the pool structure together, creating an equipotential plane and reducing the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding in Article 680. It's essential to follow these requirements carefully to ensure electrical safety. Here's a more detailed explanation of the key terms. Firstly, grounding refers to connecting the electrical system to the earth, providing a low impedance path for fault current to flow. This helps to protect against electrical shock in the event of a fault. Secondly, bonding refers to connecting all metal parts of the pool structure together, creating an equipotential plane. This reduces the voltage difference between different metal parts, minimizing the risk of electrical shock. Thirdly, ground fault circuit interrupter or GFCI is a device that detects ground faults and quickly interrupts the circuit, preventing electrical shock. GFCIs are required for all electrical circuits serving the pool area. Fourthly, the authority having jurisdiction, or AHJ, is the local regulatory agency responsible for enforcing electrical codes and regulations. The AHJ may have additional or more stringent requirements than the NEC. Fifthly, a listed and labeled equipment is electrical equipment that has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories or ETL. Listed and labeled equipment meets safety standards and is approved for use in specific applications. Sixthly, the National Electrical Code, or NEC, is a set of standards for electrical installations in the United States. The NEC is updated every 3 years and provides comprehensive guidelines for electrical safety. When working with electricity near swimming pools, it's important to take extra precautions to prevent accidents. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves and shoes to protect yourself from electrical shock. Never work on electrical equipment when you are wet or standing in water. Keep electrical equipment away from water to prevent damage and electrical hazards. If you are not comfortable working with electricity, contact a qualified electrician. They have the training and experience to perform electrical work safely and correctly. In summary, when dealing with a light niche conduit running within 5 feet of a pool's inside wall, the 18-inch barrel depth requirement of NEC Article 680.23 likely applies. However, it's crucial to verify this with the local authority having jurisdiction, or OJ, as local codes may have additional or more stringent requirements. Always prioritize safety and consult with qualified professionals to ensure that all electrical work is performed correctly and safely. The NEC is a valuable resource for electrical safety information, but it's not a substitute for professional judgment and expertise. The information provided in this explanation is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations regarding your electrical installation. They can assess your specific situation and provide tailored solutions that meet your needs and comply with all applicable codes and regulations.